Okay, welcome to Wickerson Studios. I'm going to jump in and not play with any of my Wickerson Studio custom nodes, but show how to kind of create one. Jumping in here with a Python script. I could do it in C as well, but this might be the best place to start. Open up your editor and bring things down to something simple. And what I'm going to do is just play around. I really don't know what I'm going to do, and it might not work, but we'll see. I'm going to import math as M. So I can start playing around with that. And I'm going to import random, that's R. And I'm also going to set up a random seed in case I want to use it. Seed as an input. And I'll probably have to build a points list to start with. So I'm looking off of, I'm not really looking off anything, but I'm looking off enough as R. I hate the way the Alienware computer jumps around. It just does. I'll do a points list empty, and then I'll start to do a iteration so I can get a kind of like a 3D array of points, which is pretty easy for X in range, whatever you want to go to start. We'll just start at 0, and we'll go to step, and we'll just set up a step. Start, stop, and step. And we'll have to input what those are. We're also going to do for Y in range, so it stays consistent. 0 to start, stop. Let's go stop Y. Let's do this and have a little fun. Start X and step. Step Y. And you can see where I'm kind of going with this. Maybe. As I kind of nest these loops within here for Z and range. Start, stop, Z, step, Z. Now I'm going to want to create some points. I'm going to create some pretty cool points with points random, at least in my opinion. Points will be generated as RS add points. And I'm going to use my R uniform at 0 to maybe I'm gonna haven't really decided yet. Let me make this even simpler to start with. Let's just get it in XYZ and see if we can get the script up and running. And then the points are going to be appended. The points list that's empty is going to be appended to those points, to that point, which are going to be generated again and again and again as they go. And I will want to output my points. So we're going to go points out is going to be equal to, what am I going to set it to? Just the points list. That means we have to change this to points out to begin with, and we're definitely going to want to go in here with our start, stop X, and that can be, let's just keep it simple with an integer value. I'm not going to deal with floats or decimals or doubles to start with. Integer value. I'm going to have my step X, which is going to be an integer value as well. Those are going to be much smaller. So stop is going to be a very high number. We'll keep our numbers low to start, and we'll keep this one down to step. And we'll repeat that 1, 2, down here, and we will go in and put in our Y's and our Z's, and we will put in stop Y, and hopefully the script works. Logically, I get confused sometimes, but that's just the nature of working in coding, and everybody should know that and admit to that. Without seeing, I mean, there's a few people out there that just blow me away. They don't seem to make any mistakes, but you have to wonder with the power of editing, just like film and actors, what are they really like in the step Z. So this should be enough to start, and we'll just clean up our thing and see if we can actually get it running. There's a problem, and the problem is seed seed is not defined because I didn't put it in. I may end up putting it in, so let's just take a seed as an integer value. Oops. Let's take a seed as an integer value, not Boolean, and make sure we have that. And that's going to get us past the first step, and we'll just have to throw it on. Just throw 12 in there. If you know me, I like to type 12. Okay, let's get this all organized. Oops. And there we go. Oh, I'm getting older. My eyes are going bad. And we still have a problem with the integer argument. Got a data tree object, which is very interesting. I have no idea why that got shifted to data tree. It should be an item number, item list, item. I think everything else is item. Let's try that again. And what do we got going on here? Expected got float, range integer got a float. How did I get a float? Oh my gosh. That should be integer. Maybe I didn't set all these. I thought I did. Type set int. This is a little bit of a slowdown in the setup, which frustrates a lot of people. But int. I think I just did that one. And it should be running now, giving me some points. Is it giving me some points? It is. And we'll have to take a look at what we have. And we have our wonderful box. So there it is. So once we have that up and running, and it's a nice little array, you can play off of it by stepping here. It's good control. And I've seen this nestled in some recent start stop. Why is that doing that? Let's just see. Start step. Why is my stop not working? Stopwise. Step. Stop. Step. Stop. Step. Stop. Step. I'm not sure why my stop is. Okay, hang on. Maybe it's updating now. There we go. Now my stop's working. I guess I just had to run it again. So you have a lot of control over a box doing something like this. In a box array, and you can start to do this to some pretty interesting things. Why is my step and my X? Probably because I've got it so low it's not really jumping. Interesting, that one's not running. So stop step, let me take a look in here again. Stop step, why? See, little typo. When things don't work, you've got to jump in here and find out what's going on. So I think you want to test everything after. Seed is fine, but I'm not using the seed, so we'll just take that aside. I mean, it's there for you. So we've got our X working with our X extends, fine, and we've got our Y working with our Y extends, and we've got our Z working with our Z extends. Now, what happens when you start to jazz this up with a little bit of maths? Let's not mess up a good thing, and that's usually the case of how I end up scripting. Because I mess up a good thing and can't get back to where I want, so it's always good to just double what you have. Open this one up and think what could happen in here. What if the X value started to do some jazz? And what if I had, it might be interesting to put this in. It's not really a seed, but I could start using my random. I'm thinking around, I'm looking through a text, I'm trying to come up with an idea that actually looks kind of decent. What if I set my X to, instead of X, the number that's in there? What if I had multiplied X by, and now I'm just thinking mathematically, math of sine X. That could be kind of interesting to see what that does to the piece. Now I'm just going to test that. And there we go. Started to pull it off in a direction, have a little bit more interesting play off of that. So now it has to behave with a little bit of math in that direction. So you're starting to control points. And if you take a look, you've got 840 points that aren't really coming out as an interesting data structure. They're just points. So you might have to get in here and do something different to it to allow it to be a little more interesting. But I do like the point definitions, and maybe I'll just stay focused on that and go into another thing later on about how we can start to control these points And so if we've got some jazz happening there, let's do the same to y and multiply that by math cos, just to stay safe at the beginning, math.cos, and put that through y. And remember what happens when you start to change these variables. And there we go, we've got y behaving in another way as well. So it's now exploding off in this direction. And you've got these strange patterns. Like this is how you start gaining control of geometries, to think what you might want to do. And I'm going to take this count way down. Take this one way down, which is not so exciting. And this count's way too high. So I think what I'm going to do, just to get this being a little sensible, is edit this down so it can only go up to 3 count. 1, 2, 3. And we'll leave the count at 1, not -1, but we'll leave it at 1 to 3 count. And the step count for x, we can do the same. Let's take this one down. Well, if that's working and we're happy with that, let's just, it's subtle. It's not too exciting. Let's just copy that and bring it up here, put that one into there, and get rid of this one. And so now you've got a y count that is reasonable. You get a lot in the x direction, but that's enough to play with to wrap your head around to what geometries you might end up doing, at least in my opinion. And I'm going to take my z, I'm going to do the same with 0, 1, 2, and 3. And now I can take it down to almost nothing as a count, and I'm going to bring that down to counting every 1. And I think the other thing I'm going to do is take these counts and put them on a 10 slider, which is much more reasonable. Let's put the f-stop there, and let's get rid of these stop values that seem a little high, and grab that one and copy, and now we've got a more reasonable script that we can start to wrap our head around. I don't know about you, but I can't think too much. I start to lose my mind a little bit, especially up to 10. So I've got a nice little box structure here that can be played with. It would be nice to have these points. What would we do with them? I mean, to visualize them now, it's no good to go in because the data structure is not really that friendly to take the points and put it through that list. I mean, it shows you a little bit of a wire display, but they're not really split up in any way, those points. And I guess what you could do, and this is another way to come at lists, we're done with our script for now, even though I am tempted to show you the power of going in to these points and trying something a little different in your maths. And there's one down here that just blows me away every time I use it. And I'm not much of a mathematician, but I believe it was the log 1p. And if I apply that test, it does do something and stretches things out. It does a pretty interesting thing to the numbers. And I've always enjoyed kind of what that does. And maybe going back down to the script and going back to the cos, what if I was to go in there and play with the z that way? So z times m dot log autocomplete and z, and see what we get there. Test. We get this kind of interesting play that there's a shift in how it kind of pulls. Well, the y is pulling out in the direction of 1. Z is being affected. I just like these patterns, and I think of them as points. And with those curves, sometimes I'll take, before I do anything with those curves, I'll go in and I'll deconstruct points and see what I can come up with. So let's blast those points apart. And the x values are coming up high and low. So you can say things like, if x is larger than so much, you want to keep it. You could start to control your streams by controlling the data. If that's not making sense, I'm just kind of running my head over it right now and thinking, okay, what would I want to do to that? What happens when I take that value? I keep a minimum on it. Let's just construct some different points and see what we end up getting without thinking too hard about it. Let's construct points here and here and here. And let's grab the y and the z, the x to nothing. I have a nice little pattern here. Let's grab the x and the z and see what I end up getting here. as a list. Still a little too complex for what I want. And then I'm going to grab the Y and the Z here. I've got all these different point sections or ways of treating these and what I would actually do to them. I am interested in possibly just thinking out loud to myself. What happens? I had an idea there. It comes into my head and it disappears pretty fast. It might be nice to see these curves, each one with the spheres. What is being generated here? I might take a pause and see if I come up with something great. Strange. Uses a little bit of math. What I did was I just took those points and I thought to just, because they're facing different directions, these ones and these ones are kind of similar, so they're not really worth playing with. But these two are fairly easy, and if I just did a polar array with a small count on those points in this direction and this direction, I could build meshes out of those. And baking those meshes so they're not exactly, valid, but they do produce this very interesting, there's a few problems within here, pattern that I hadn't seen before and I probably wouldn't come up with as a mesh. And if you think about those as this structure, let me just push that down here. Let's do another little bit with the mesh, and you can write into your scripts down here things like enumeration values. Like if you can go in here and say, okay, if if I'll just make a condition, if enum is equal to 0, then do this, points append. And then you can go in and say things like, go back, and if you just have another condition, else, I have to create the variable enum, else enum, actually you just say else points, you could just do this to the points append. I'm just going to grab this whole thing here, copy, and put it in here and say else do this. And because this one, maybe I just want to throw in something simpler like a sign again in the Z direction. That totally blew it apart. Why? Why did that blow it apart? Enum is not defined. Of course, I just said that. Let's add our enum. Something as simple as that. You could have a Boolean set as a Boolean, but I usually don't set Booleans because I like number sliders. So I'm just going to grab a toggle integer from 1 to 0. And as I do that, it should be able to grab different enumerations. So if I take that to the 0, it should be running the first one. And there's the second one. So it's not much of a change. The amplification of the Z, not so interesting with that. So what I might do is go into another math tool and say, okay, well, what's one that I think might work geometrically? I know cos would for sure. Powers are going to be nuts. They're going to go through the roof. Tangents are going to be absolutely insane. And it's probably going to crash my program if I do something like that. So let's take this back and see what happens. Nope, it didn't. It just pulled it down. So you can play around with this and play with your maths in here. Go into your meshes, and you have a lot of control in your scripts, and you'll see that there's an invalid mesh here that's baking. But with that, that's the second one that came about because I printed that one. And just from a little bit of maths, you get these totally different geometries that, you basically have to go back into Rhino and see what's wrong with them. But since they're surfaces and visualizations, you can produce some pretty interesting architectural platforms and frames. And actually, if you think as a mesh, this actually isn't too hard to think about getting around to fabricate. This is the one that I printed there. That's the other one there. Well, let's just be nasty. Let's take a tan here. And there you go. You just exploded it out in that direction. You've got a completely other geometry to play with. And that's really how I come at this. I really don't overthink it. And I know there's obviously things to clean up and fix. But with those 3 platforms, I probably wouldn't have produced those meshes. I probably wouldn't have grabbed paper and decided to do that. You could always scale this one up if you thought. I mean, obviously you were getting to something you liked and you wanted to come in and play with it in Grasshopper, in Rhino directly. So I'm just going to take the bottom one, make it the biggest one, and the other one's going to be the other one. And we're going to go down to the top, and we'll have a little bit of fun over here now that we've made this script. And we'll hit save. It's a little bit of mesh creation, a little bit of point understanding, going into the Python node and having a lot of ability to use this script to jazz up this geometry. And I think if you start using the computational power of Python along with the parametric power of Grasshopper, you can go back into the computer-aided design modeling that you're used to doing in Rhino, and you're going to generate things on a light speed, adrenaline, whatever it's called. Give the horses, I guess it's adrenaline, speed, and you can be able to do things that you never once thought you could do. So I'm going to just close this out with my Grasshopper over here. Probably keep my Python. Actually, I can close it off, and we'll go back in here and have a little fun with just some simple little finishes. Because I think people enjoy that when I do that on the video. You don't have to watch it if you don't want to. The gradient color can be set to something yellowish and dark, and we can get down in here and have 3 shades of blue on the material. So let's just do that. Let's take a shade of a paint. We'll add 3 paints, paint, and paint, and we'll go into here and make that one color a little blue, faded. Okay, and we'll take that, put that on the first one. It's just something simple. And then this one we'll go back over to I thought I added another one. We'll take another plaster, and we'll do a color blue as well. Bring it into here a little bit. Okay, and do a set object. And this one, just because I like complementary colors, we go in here and grab an orange. And actually, we don't want to change that one. I'm going to cancel that. I'm going to add another one and add another. We'll add a metallic orange. I'll just jump in here and grab a little metallic orange, which is kind of grotesque, but it beats doing EMAP and surface edits. Let's just pop this one into here. And there we go. We've got something that I probably never would have made, metallic, plaster, and think of these as kind of mazes, or you can think of them as surface design on forms. And once again, they're informed by Grasshopper, Python, and you could write it in C# if you wanted to. You can make little nodes like this. This actually isn't a bad little node. And just a final example, what did it do? What if I called it, I'll show you how I usually end up making these my nodes. Is this kind of a math function? So what I'm going to do is go into here and I'm going to call it, what did I call my math tools? Math library, Wickerson Studios math library. We'll just give it a fun name and call it Wickerson Studios Grasshopper math library enum. And I think I've already called something that, but that's a good enough name for what I'm doing. I'll go in here and I'll go to File and I'll make a user object. I'll call it that. I will put it under the Maths tab because I have lots of little categories for these. I'm going to go in and find my Wickerson Studio icon, and I think with the Math tab I'm actually pretty happy to call it that, and it should pop up here, and there it is. So what you can do now, Math Library enum, you can grab this, pop it down into here, and get rid of this one. And it'll need all the jazz to make it work. So you need your Z step, your Z stop, your Y step, your Y stop, your X step, your X stop, and your seed. And you're in business, and you've run a little script. You can save it. I'll make that available for anybody on GitHub that wants to support my Patreon and start to have fun with this. There's no ends to it in sight. I'll take this and shrink it down. Go see the script whole. And there it is. And that's the best colors in the world, but it's something we'll look at. And I do like the top one the best, actually. And I have to wonder what this would look like on all views. And usually you end up just playing like this. Like, why not? Go into here, put your technical on. I hope it doesn't have a problem. Pen and artistic. So you've got this kind of sense of what's happening. pen and ink drawings that you're not going to sit, and technicals being held to red, so it's kind of ugly. And there, got your little space station with spaceship. 25 minutes. Thanks for watching.